Później się to zmieni.
Hello everyone, my name is Adam and this is
Damien.
So we are here today to talk a little bit about eye tracking and predictive eye tracking. So we live in the future now, so eye tracking was changing over the past decade. So around 10 years ago or 15 years ago, there were times that you needed a special equipment that costs many thousands of dollars to run eye tracking research. As you all probably know, you can now run the eye tracking research with webcams. But now, since AI is everywhere, it is also touching gently the eye tracking field. And we're here today to talk about it and also how eye tracking is changing in general.
Yeah, me myself, I was a bit skeptic about AI, especially when it comes to eye tracking. But once we started to dig more into details and how it works, how we could probably provide it, I must say I'm really excited. But yeah, we'll talk about it.
Yeah, and I can definitely say that he's more than just excited. He spent like the last 6 months in his backend developer's cave, training some models, doing some crazy stuff with the data collected with eye tracker, with the webcam eye tracker, to see how far we can go with the predictive AI. But maybe let's start with the beginning. So AI is not only used for predictions, for being a predictive AI engine. I don't know if you are aware, but we are also implementing AI solutions, machine learning model solutions, to improve the eye tracking quality for the webcam-based eye tracking as well. And I must say that we are on a great place, in a great moment, because we are observing first results that are coming in from our pre-trained model. So the accuracy of the new webcam-based eye tracker is beating the current accuracy of the previous algorithms that we're using, which is great, and it also allows wider head movements, and the calibration is not anymore made out of around 40 dots, so it doesn't last 40 seconds, it lasts around 5 to 10 seconds, which is amazing. This is still work in progress. We're doing it with European Union funds, and probably the first releases will be around the end of this year. But we're super excited that AI is helping us out to improve the webcam-based eye tracking accuracy in general. But on the other hand, there is also a question: why even run eye tracking research, since everything can be predicted? So what can be predicted?
Well, some people say that everything can be predicted. I've seen many startups doing predictive eye tracking, attention prediction, or even like predicting like really big groups of people. Like you can virtually speak to like 1,000 of people to ask them any question about your product, your idea, and validate it before you start talking to real people, which, as we know, can take quite some time, especially when you have some specific target group that you need to somehow reach. So there is a lot AI tries to cover. What it can do right now, well, we'll try to show you what it can do when it comes to eye tracking and predicting visual attention.
One question here, because we're talking about eye tracking data for groups of people. So on a daily basis, when you're running eye tracking research, you get an individual participant data. Is it something that you think can be also replaced with AI? Like, for instance, eye tracking can be used for user experience sessions. This is kind of tricky, as individuals will move in a different way. They'll think about something else. So are we talking about masses, groups?
I think everything is possible. It also basically depends on if you can feed the AI during the training with proper data. But I think the easiest and the best scenario for AI is to give you like generic answers regarding some group of people, not individual. But that was also on my mind, and maybe we will also do some experiments if AI can behave like a single person to watch some stimuli, go through some website and so on. That definitely is something I was considering. Right now, we focused on predicting like visual attention for a group of people, because that's like, I think in most cases we've seen, especially right now we have focused on the shelf testing, virtual shelf testing and so on. So this is definitely something that our customers test on bigger group. So that's what we have been focusing for the past months.
So I don't know, just brainstorming, looking forward, we might not need people in the research at all, since we can predict such a delicate data as behavioral data. Then we can probably predict anything. Then what will happen to research on humans?
I think the research will just become faster and better, and this is basically just like using computer to do your work, because it can be much faster or help you do some stuff easier in a more advanced way. I think it will be quite the same. I think that quite soon we will probably switch from thinking that now we live in this new era of AI. We will just consider it as computers, using computer that can do new things because they are more powerful. And we use computers in our daily work for decades. It's sped up everything a lot. So this will be the same with AI. We will see significant improvement in new things we can do and how fast we can do it. The main improvement is that now we can communicate with a computer more like with an actual person, just describing our thoughts, discussing with it. And thanks to that, it is much easier and more efficient for us to do something. Still, I think we'll all have to be doing our work. We just probably will be doing it much faster thanks to AI or the new way we can use computers.
Okay. So far on the market side, we observe that eye tracking is still out there, and the predictive AI for predictive heat maps, basically predicting where the attention will go, is actually not a new thing. So it was out there for more than 4 or 5 years, and there were several attempts, several companies that were doing it, and they are doing it right now. So what was the biggest issue with these models, with these heat maps? You said at the beginning that we were very skeptical. I remember these times.
Yes, we were both laughing when we saw some heat maps on LinkedIn and other places posted by some people, which were supposed to show how people look at certain things. And after years of looking at heat maps every day, seeing thousands of them or even more, you can easily tell if it's something that's very likely people would look at this design this way or not. And maybe I will just show you asked the interesting question. What's tricky about it is that, for example, if we have a heat map, then okay, some designs are obvious. When there's something big, shiny, with a lot of contrast, you can easily tell that probably this will be easily noticed, and many people will notice it. But when it comes to more complex heat maps, it's also a tricky thing, because we can visualize it in many different ways. So how you decide how to present it, it's also researcher has to do some thinking, has to have some knowledge, intuition, how to present the data, how deep would he want, she wants to analyze it, what's important, what's not important, how big amount of attention should be considered, that this place is something to talk about, to do something about, or it doesn't really matter. So also when I saw like the predictions from other solutions and from our like early prototypes, I was like, okay, but what would we really want to accomplish? What's the goal of the prediction? Mm-hmm. Is it like a heat map that just has some red points on it, but what this red or green or yellow should really mean? Mm-hmm. And for example, here by default, we can see in RealEye and in many other tools, like the default heat map is built on fixations, mm-hmm. but it can also be built from gazes. Then it looks quite different. Mm-hmm. So that was like the first thing when I saw a heat map that looked quite promising. I was like, okay, but what does that heat map represent? And that was like a lot of thinking, testing, mm-hmm. what we would like really to predict.
Sure. Like from RealEye point of view, we recently got to the point where we discovered like the three main pillars for every eye tracking measurements. So we are detecting how fast people are noticing certain areas, the areas of interest, how much time they spend inside while looking at these elements, and what is the reach, meaning what is the ratio, how many participants have noticed that. And well, it's hard to visualize all three on the same heat map. So that's, I assume, is your point, that heat map is one thing, it's just a matter of visualization, but there's always the matter of metrics and data behind. And this is where it gets tricky, because the AI needs to predict what type of attention you are looking for, and yes. what it means good, because I don't know, looking fast, what is better? Do I prefer more people to see my logo type, or less people but faster? So there's always a question of what is important for my research. So what is my research hypothesis? And I assume that working on this type of these components gave us some kick when it comes to predictive AI, because we were now able to see what we want to achieve.
Yes.
Okay. Let me just add on top, answering my question. Like I was for the years, I was quite surprised that each predictive AI was bringing different results. And since we were talking about just heat map visualization, mostly because some of the tools already brought some area of interest analysis as well, then it was like a random decision which tool I'm going to use, because I'm going to get different results. So I believe that the ground truth is a comparison to real eye tracking data, real eye tracking predictions. And I think we did a pretty good job here. I don't know, maybe you can elaborate about it a little bit more.
Yes, the ground truth, which means basically what do we compare to our solution? I mean, when it provides a prediction, how can we tell if it's good or bad? And we definitely wanted to focus on real eye tracking data collected from thousands of people, and we did that. There are some open sourced benchmarks that also you can use to like train and validate how your solution works. But similar to like for when it comes to the heat maps, we might want to predict something a bit different than simply just I don't know, fixation duration or fixation count. And that's why we compare our predictions to real data. We have lots of it. And that's what we're using as a ground truth. Mm-hmm. And also it's worth noticing that even for the same stimuli, if we run a study for, let's say, for 100 people, on 100 people, the heat map might look noticeably different. So it's also like there is no ground truth for every image that would always be true. I mean, depending on how many people you ask to see that stimuli, from which place, maybe, I don't know what kind of mood they are, if they have something else on their mind, and the heat map might still look a bit different.
Yeah. And that's basically why real eye tracking is quite important,
definitely.
Because you want to measure different people, different ages, different demographics, different I don't know, intentions. So that's why probably real eye tracking will be there to make sure that you're measuring the right people. You don't want to test, I don't know, cosmetics for women on a bunch of old men, right? That's pointless.
Yeah, and I'm quite sure, and I hope many neuromarketers are watching this now, so I'm quite sure that they know that if some people are familiar with a given brand, they will probably notice it across different products in a different manner. And yeah, that's right now, that's not possible to be checked with AI, because we would have to, like, I don't know, it's even impossible to get all the data from people. Are you familiar with that brand, in what level, and so on. So right now it's like predicting attention when it comes to a random group of people.
So giving this, as Damien mentioned already, we are providing some reporting tools for predictive attention, and we currently focus mostly on shopper research, product packaging. So where we are and what should be the pipeline of running a similar test on packaging. So I assume that it's quite risky to run predictive AI on a product packaging and then just release the product to the market. So it's rather made for pre-testing.
Yes, I think that, like, the best way to approach it is just to use predictive AI to do some pre-testing, to make sure that the designs we want to continue with, and spend a lot of time and money to validate on real people. That's what predictive eye tracking is, I think, very nice tool for, because you can test the design much faster, adjust it as many times as you need, and compare it against other designs, see what parts of the design get enough attention in order you would like to get from the package. And then when you have your, like, the best candidates, you can easily do the real research with real people, to also ask additional questions, probably in some survey and so on. Yeah, so I think it's all working well together. Just at different stages, you might want to use different tools.
Cool.
Okay, anything else we would like to cover here?
Yeah, maybe I think we should go and move few steps forward where it's going to be soon, because right now we are supporting mostly shopper research, but we're not so far away from supporting video content, websites, advertisements, like basically anything that captures visual attention can be run through the same models to detect what is going to bring the attention from the screen,
maybe not exactly the same model, but similar one, because I think we will just create like specialized model for every task to, or well, we will see. We are still in a phase where AI also at our company is developing fast. We checking many different approaches, and we will see right now I'm really happy about the results we get, especially for the shopper research, the packaging virtual shelf test.
Sure.
Like mean average error around 10% is really nice. And whenever I browse in some tool to see the comparison between heat map built on actual eye tracking data and the predicted one, and I see how close they are, then I'm really excited about it. Yeah.
So we're getting one question. Can we show a little bit more, like really show something on your screen about the attention predictor? So how
Sure.
the reporting looks like, and what type of ingredients the reports have. If you need some time to prepare, that's fine. Like you can open a new window. But what's quite interesting for me is that we provide several, like many different layers for each report. So it's not just one heat map for individual image, but this is a heat. There are several heat maps built on several different levels. For instance, first half of the second of observing, first second of observing, first 2 seconds, 5 seconds, 10 seconds, and so on. So you can see how this heat map is getting increased in time, how the data is spreading in time. And this is also divided into 4 different scenarios. For, as I mentioned, we do have the speed component, hold, and the ratio component, meaning reach. So we do have, you can think of it like a grid of all these components divided for different time thresholds, meaning you can detect how fast people are noticing or how the attention is being distributed in time. And that's quite interesting, to be honest. I assume you don't have anything ready right now on your laptop to show?
I mean, we can go quickly presenting the predictor, but yeah, the things that you mentioned, for example, it's so obvious when you do work with real eye tracking data. Like on this dashboard, you can see that you can, of course, select the time range to decide what's happening, how the attention spreads, what's being noticed first, and so on. And those 3 like the most important metrics, like time to first fixation or average time to first fixations, and ratio or reach and dwell time. Those are very important and should probably in some cases, or in most cases, also be considered separately, but also like in overall, what's the like general visual attention index. That's why we created it.
The visual attention index that is right over here on the right.
So just like for this data based on actual people from real eye tracking, where you can get data for different time ranges and for all those 3 or even 4 visual components, as we call them, you can get exactly the same from our predictor. Like the easiest, the most obvious way to see how the predictor worked, what was the prediction, is obviously a heat map. So as you can see on this example, yeah, that's the heat map from the attention predictor. But yeah, that's like what does the hottest place, the red, mean? What does the yellow mean? What's the ratio between those areas? So also like you can create multiple areas of interest in RealEye dashboard. Obviously you can ask about those metrics when it comes to predicted values. And what else? I think it's really worth mentioning, because I know that there are some really interesting projects regarding predicting attention, but they, as far as I could find out, they are most likely trained on some open source data sets with like 50, 100 people looking at a couple of stimuli, and they can predict that, but they are very limited because of the training data set. And as I've mentioned, we have lots of data that we can use and we have used for training, which is like almost 2 million eye tracking tests. It was like almost over 12,000 unique images. Those are the stats for the model we used for package design. We have even more data for other type of stimuli. This gives insane amount of eye tracking sample fixation point gazes and so on that we can use. And we made, apparently, as it looks by looking at the data, it really made the prediction really good. And as we've mentioned, you can get the heat map for different time ranges. You get a viewing path, which element was seen as the first one, second one, and so on and so on. And you can analyze it even deeper by analyzing based on different types of attention component, which is like speed, reach, halt, all combined together.
So someone basically is interested in seeing how it looks in more, let's say, on deeper level, then we are happy to share a sample report. And if you are even more interested, we can run the first batch of reporting for you to see, so you can see the value by yourself and decide whether that's something that you want to include in your offering or just start using it for your own analysis.
There's really a lot beneath all of that, and what I really enjoyed when working on this, because we started obviously with creating just a heat map of whatever that would be, and we really wanted to make it meaningful, to give like those juicy, meaty data for analysis, and as close as possible, of course, to the real eye tracking. And yeah, we did it. If you don't want to go into details, you can always just create an area of interest and analyze like only the visual attention index to compare which product, which part of the design got more of the attention. But if you like to go really crazy with that data analysis, you can even analyze it on a cell level, which is almost like on a pixel level, and you get for each cell data for those 4 attention components and for 5 time ranges, which is insane amount of data you can.
I've seen the report and there's a lot of layers on it, definitely worth checking. Okay, I can see that there are 2 more things to cover. What would be your dream future?
Future or feature?
Feature.
Regarding this, we have like a backlog full of ideas, and I think that it's already quite easy even just to put some predictions from the system to some ChatGPT or other solution and ask it, write me some nice overview report, what all of that means. My dream is that AI can help researchers much more, but it's not that easy, as it takes years of experience and really a lot of knowledge to create some deep insights. And maybe one day, well, AI world is going forward really fast, but so maybe sooner than later. But yeah, that's like automated, fully automated report with recommendations. That would be nice. Also, we are working on a benchmarking solution module, so you can upload your design and you will get an information how my, let's say, juice, apple juice compares to apple juices from other brands. And yeah, that's also coming sooner than later, and we're collecting the data to create such a benchmark. That would be definitely very, very nice. And also recommendation about design, because I think that it's there are some standards on the market, especially regarding the packaging, but also in UX and other areas, where there are some thumb rules that you can follow, some ratio between how big the logo should be, how big the brand name, how big should be the information about what kind of juice is that, and so on. So yeah, that something like that, some just to validate, okay, the base things are there in your design, don't worry, now just make those minor tweaks to get as much out of it as possible. So that's from my side when it comes to
I'll
new
definitely
features.
+1 for the benchmarking. I know that it's hard to say what a number means on your heat map, on your report. Like, what is it good that my logo type got 23 visual attention index? So I don't know. So having benchmarked it among different products from the same category, that sounds really, really, really amazing. So definitely +1.
Yeah, but still, I think the researcher is needed here to figure out what's our
important,
goal,
how
we want to present our product, and what we want people to remember after seeing it.
That depends on a lot of different things that cannot be included in. Well, probably everything can be included, as you mentioned, but I don't know, if you look at the Coca-Cola packaging, like, it's totally different than different sodas. Like, they don't have to care about explaining what does it taste like. They're just branding all over the can. So it depends on the stage. Like, if you're releasing new product, if you're a new brand, then you want your logo type to be, I don't know, more visual or less visual, less attention, to capture more or less attention. So it all depends on the phase where your product is. But again, probably AI will be able to support you there to tell you where your product is on the market and how you should position it. But yeah, probably we're looking into the future. But that was the question about. So yeah. Okay. So we're getting to. I think that's it. Yeah, we're getting almost there. So last thing is that if you want to contact us or get some sample reports, then you know where to find us. Please follow us on LinkedIn. We are posting some fun stuff there regarding Attention Predictor, but other tools that we're working on as well. And if you'd like to test your product design before making your first purchase, then we're happy to provide you with some insights, reports, or just scheduling a call so you can understand more how it works.
Yeah. Okay, that was nice. Our first webinar. I hope that we will have much more of them. It was nice to talk with you, and finally we had some time to talk about the crazy stuff we're doing here.
And there's not much time to market it properly, so we're happy that we ignite. Thank you.
Okay, thanks. Bye.
Good day.